Hey, welcome back. For today's lesson, the factor label method. This is a method we'll be using for a lot of material in chemistry. This is a very important skill to pick up. It may not come to you right away. That's okay. Just keep working with it. You're going to see it over and over and over again for the rest of the year in this class. So keep working with it. Keep practicing. Don't blow it off. It's going to be something that's very, very important. Today, we're going to start with some basic metric conversions and some density calculations. So let's get started there. Alright, so factor label method. Again, it is a must. We have to be practicing this method. If you have other ways to do it, you got to do it this way. And I highly recommend that you learn this way now. While it's simple, long term you won't regret it. We're going to use it a lot this year. So here we go. We are converting 0.84 meters to centimeters. Number one, and yes, I need you guys to do this, write down the unit that you're trying to determine with a question mark. So we have 0.84 meters, we're trying to determine centimeters. So I'm going to start solving this problem by writing down a question mark, centimeters. There's the unit we're trying to determine. Step 2, let's put an equal sign and the given measurement. So 0.84 meters, equal sign, 0.84 meters. We're trying to figure out how many centimeters will give us 0.84 meters. Third step, we're going to use our conversion factors that hopefully we're starting to memorize. How many meters are in a centimeter, how many seconds in a minute. And we're going to use that conversion factor in order to convert, in this case, meters to centimeters. Whatever unit is the numerator, so in this case meters, be sure it's the denominator in the next step. So we're looking to cancel out meters. I set mine up by what I call the picket fence, or what you'll hear called the picket fence. So again, there we have meters is on top here. We need to divide it out, so I have meters on bottom. I have it memorized as 100 centimeters in 1 meter. If you prefer to call it 0.01 or 1/100th of a meter in 1 centimeter, that works just fine as well. But make sure you have, again, your units are correct on the bottom. Meters, meters. Those now cancel out. They have divided out. Meters divided by meters cancels out. You're left with centimeters. That's good. That's what we were looking for. So final step is determine how many significant figures you need to keep and do your operation and make sure you have the appropriate number of digits in your final answer and your appropriate unit. A quick reminder, anytime we go from English to English or metric to metric, it's an infinite number of significant digits. So I know we might be looking at this 100 right here and the 1 right there, and you might say, hey, both those numbers only have 1 digit. Well, yes, except that it is a defined value, a defined quantity, so really they have infinite digits. So we're going to look back to our original measurement of 0.84 meters. That's 2 significant digits. Remember, zeros on the left never count. So there's our 2, the 8 and the 4. Our final answer should have 2 digits in it. 0.84 times 100 divided by 1, 84 centimeters. Make sure you include the unit there. Let's try one more example here. Convert 0.143 hours to seconds. All right, following our rules, we're trying to determine how many seconds, so question mark seconds. We have 0.143 hours. All right, first step, I need something with hours on the bottom. I need to cancel out that hours. Off the top of my head, I can't go straight from hours to minutes. Some of you guys might be able to. Congratulations, fantastic, you're allowed to. But me, personally, I'm sitting here thinking, hey, I can go from hours to minutes. Again, notice that's not what I finally want in my final answer, but it gets me a step closer. 60 minutes in an hour. Hours cancel out. They divide each other out. Now I can go from minutes to seconds. Again, the minutes will cancel out. I've got 60 seconds on top. Here's that huge advantage of starting off your problem, question mark, units that I'm looking for. I'm looking for seconds. I have seconds. Everything else is canceled out. We're where we need to be. Now it's just a matter of doing the calculation. So I plug in 0.143 times 60 divided by 1 times 60 divided by 1. I always multiply across the top, divide out the bottom. If you know the identity property, you don't have to divide the ones. It's not going to change anything. Same if 1 is ever on top. You don't have to multiply the 1. It's not going to change anything. So 0.143 times 60 times 60, 515 seconds. Again, double check significant digits. We started with 3 of them, 1, the 4, and the 3. There are exactly 60 minutes in an hour and exactly 60 seconds in a minute, so these digits don't factor into play. So we should be limited to 3 significant digits in our final answer. There they are, the 5, the 1, and the 5. All right, we're also going to take a look at the factor label method when solving density calculations today. So, formula for density is mass over volume. Hopefully we're aware of that, but to be honest with you, we don't use this exact formula all that often. What do we see here? The conversion factor, that's right. Mass over volume. Wanted to point out, we used to do a lab where we changed the water temperature and watch how the density changes. So just kind of pointing out that density is dependent on at what temperature you're taking the measurements. So just something to point out. Again, here is a chart with some common densities. Again, notice that unit, grams per cubic centimeter. That's a mass over a volume. Let's take a look with how that works in a mathematical equation here. Alright, so a couple of examples. A copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What is the density? Okay, well, I have to remember that density is mass over volume. So I'm going to set up my problem the exact same way we were 2 slides ago. I want my final answer to have mass, grams, over volume, cubic centimeters. I'll go ahead and push the equal sign, or write the equal sign, and plug in the values that I have. I have 3.1 grams. I have 0.35 cubic centimeters. Hey, look at that. These are the units that I want. I don't have to do any conversion. I've got my problem set up exactly how I want it. I just have to divide 3.1 by 0.35. I got 8.853 grams per cubic centimeter. That's a density, mass per volume. And finally, check my significant digits. 3.1, that's 2. 0.35, that's 2 digits. This is a division problem. We want 2 digits in our final answer. So 8.8, that's it. I take a look at the digit after 8. It's a 5. That tells me to round up. So 8.9 grams per cubic centimeter. Put a box around it. You're done. Next example. The mass of a cube is 10.932 grams. The length of an edge is 2.36 centimeters. Determine the cube's density. So we've got a couple of problems to solve here. First of all, we have to think about what is a cube. Well, a cube is a 3-dimensional object where every side is the same length. So if we have one edge that is 2.36 centimeters, that really means we have 3 edges. If we want to find the volume, so again, we're looking for density, grams over cubic centimeters. There's our volume. If we want to find the volume, it's length times width times height. Since it's a cube, all 3 of those are going to be the same. So let's go ahead and set up our problem. We have a mass of 10.932. Because we've taken our time and set our problem up correctly, we know that we want our mass on top and then our volume on bottom. Length times width times height. Centimeters times centimeters times centimeters will be centimeters cubed. And once again, we do not have any conversion that we have to do. It's a simple math problem. 10.93 divided by 2.36 divided by 2.36 divided by 2.36, 0.832 grams per cubic centimeter. There's our density. You can double check your significant digits. 10.932 has 5 digits. 2.36 only has 3 digits. So our final answer is limited to just 3 digits. There they are. Our next example. Determine the mass of a material that has a density of 3.6 grams per milliliter and a volume of 35 cubic centimeters. Hey, so finally we're not actually looking for a density. The first two we were looking for the density, mass per volume. This time we're looking for the mass, and we're given the volume. All right, so again, I'm going to start off. What am I looking for? Question mark, grams, that's our mass, is equal to, hey, here's a little trick. Anytime you can work with a number, so I could start with 13.6 grams per milliliter or 35 cubic centimeters. Notice how that cubic centimeters only has one value, whereas the 13.6 has 2 units of value, grams per milliliter. Anytime I can work with just one, I'm going to start with that one. So grams is equal to 35 cubic centimeters. That's my advice. 1 unit, let's start with that. All right, first setup, milliliters and cubic centimeters. How do we get one into the other? Well, actually a very, very simple calculation, a very simple conversion. This was on the first day of notes. I said it'll be very helpful for you to memorize these. Hopefully you have. 1 milliliter is the exact same as 1 cubic centimeter. So that's a very easy conversion. Very helpful for you to memorize that. Cool. Now I've got milliliters. I don't want milliliters in my final answer. I want grams. So I've got to get that milliliters canceled out. Put that milliliters on the bottom. Now milliliters cancel out. And 13.6 grams per milliliter. That grams goes on top. The milliliters cancel out. And I'm left with grams, which is exactly what I want. I've just got some math left to do. 35 times 13.6 is 476. Let's check for appropriate digits. I started with only 2. 13.6 has 3, but that's okay. I'm limited to only 2 digits here. I need to round 476. 7 is my second digit. 6 is enough to round up, so I do. 480 grams. All right, our final example here. Determine the volume of a material that has a density of 13.6 grams per milliliter and a mass of 76.2 grams. Very similar problem as the one above. There's going to be one little trick. So we're looking for volume. They didn't tell me what unit, so if you want to do it in cubic centimeters, go for it. I'm just going to go ahead and say, hey, we're working with milliliters. They don't tell me exactly which volume, so I'll work with milliliters. Again, we have our choice of 2 units or a number with only 1 unit. I'm going to go with just 1 unit. So how many milliliters and 76.2 grams? Need to cancel out grams. How do I do that? I need grams down here. Here's the little trick. 13.6 grams in 1 milliliter, or another way to say it, 1 milliliter and 13.6 grams. It's the same number as up here. I know it may look upside down, but it's the exact same number. I just need to watch and make sure that 13.6 grams, the 13.6 goes with grams, and the milliliter goes with the 1. Cool. So grams cancels out, and that's the important part. I'm left with milliliters. It's exactly what I want. Just a calculation now. So 76.2 grams divided by 13.6 grams, and we're left with 5.60 milliliters. 3 significant digits, 3 significant digits, 3 significant digits. There we go.